Okay, so my talk is on similar to the previous talk is on security, but it's a different part. Kubernetes security, but in terms of secret management. All right, cloud native way. First of all, my name is Iliri. You can call me Ileri, but my full name is Ileriayo Adebiyi. I'm a cloud native engineer at Container Solutions, and I'm an ambassador at CNCF just recently. I'm also certified in the three Kubernetes certifications. Yeah, so this is the agenda. We're just going to look at the problem. We're going to look at some solutions or the solution. And we'll look at the project. We'll see how it works and do a demo. Let me just check the time. All right, so let's examine the problem. We're looking at cloud native secret management, basically. And first of all, let me start by talking about cloud native. There's something I came up with last year. That's how I like to see cloud native. If you ask people what is cloud native, you get several responses. And in fact, the company I work for began a webinar, all right, because of that. Or should I call it a webinar? It began a newsletter, right, because of that. And they were asking, what exactly is cloud native? Because people just, gave random answers to that. But this is how I see cloud native. So cloud native is to the cloud as computer science is to computers. Now, what do I mean? Um, I did computer science in school, and I know that computer science is not the study of computers. All right. So that's why I said cloud native is to the cloud, as computer science is to computer. So computer science is the study of problems, solutions. All right. That's why we say algorithms. And cloud native can be seen in that way. It's not. It started off as a cloud movement. All right, but it's not only the cloud that it relates to. All right, and one of the very popular cloud native technology that we know is Kubernetes. So Kubernetes was, started by we probably know some of us probably know the history. Google developed a software. They brought it to DockerCon, I think in 2014 or 15, and they wanted a share of the cloud market. AWS had a share. AWS, yeah. But so Google brought this software, and it was supposed to help them in that cloud journey. All right. But of course, Kubernetes has grown bigger than all of that. Kubernetes can be used on several platforms, on premises, in the cloud. So cloud native is not necessarily the cloud. It helps you to do cloud engineering the proper way or the right way. You can say it that way. So let's look at this problem of secret management. Now, this is a simple application, all right? And you have maybe a database and the app, all right? You connect to the app, your simple app, you deploy it to any platform, any server, Linux server, but you begin to scale, or you begin to talk about scaling your application to handle loads of traffic, you know, and typically what comes to mind is you want to have a replica, all right, or replicas of your application. Then you probably say, okay, let's have something for high availability, let's have multiple databases as well. All right, that's what we have there. So as you begin to scale, this is what your system will look like. All right, multiple replicas, your code checked into Git, came along, to help with automation and all of those things. So yeah, this posed a big challenge. How do we get secrets into our cluster securely? How do we ensure that we do not, for instance, put secrets in GitHub? All right. Some systems that we have in place, they check against all of those things. All right. So static code analysis can tell you that you can't check secrets into version control. Right? But we need to be able to handle secrets securely. So what comes to mind is, how about we store our secrets in a secret manager? Kubernetes is not a secret manager. All right. That one is very clear. Kubernetes was built specifically for something. All right, but that's not secret management. So creating a secret in Kubernetes is fine. However, it's not as, for instance, you write the code, the YAML file to create a secret, you put it in GitHub. First of all, you have an open, okay, you can say that my GitHub account is private and things like that, and things like that, and yada, yada, yada. But a better approach is to store those secrets in an external, secret manager, all right, where things like rotation can happen. GitHub will don't do that for you. All right. You want to have, systems that are built specifically for managing security secrets, things like SSM, AWS SSM. For those of us that use AWS Secret Manager, you can have Azure Key Vault, you can have HashiCorp Vault. Those technologies are built for secret management. So then the thought comes to mind that how about I, you know, sync secrets from those secret managers into my cluster. I think that's a better way to have it. But Kubernetes doesn't have that functionality. Now, we developed something, and when I say we, the company I work with, all right, developed an open source software, all right, to do exactly that. Now, what's the appeal of syncing secrets? So you said that you can have, secrets in things like HashiCorp Vault, in AWS Secret Manager, in just name it, whatever secret manager that you use, you can have your secrets there. They are easily rotated. Maybe after every 30 days, the secrets are rotated. They are checked for, you know, whatever checks that your secret providers offer you. So you can integrate with that. That's one of the appeal. Now, of course, you're keeping your secret somewhere where it's secure in a service that's designed for it, and you're abstracting all of that technicalities. The implementation detail is handled by the secret provider. And of course, we already mentioned that you can use the services like encryption at rest, all right? Have easy rotation of your secrets. Now, with this, you can declare secrets in source code. I'll explain that as we go along. And you can also, grant accesses to the right people in that way. But let's see how this tool was built. So we developed something. I said that we developed an application, an operator, all right, called external secrets operator to help you do exactly this. Somewhere around 2020, during the COVID, some people sat down and they were looking for this solution. How do we do this? All right. How do we start all of these things? GoDaddy was already working on something. All right. It was written in JavaScript to do exactly what we have defined. And some other people, you can look at their URLs there, they were already building things. But of course, the company I work with, Container Solutions, was also building external secrets operator. However, it was written in Golang. So we sat down, this one here, the two case stars, that's the one from GoDaddy, very popular because of course, GoDaddy. And so all these people sat down and said, why don't we merge this and have a singular solution? And look at all the discussions, just screenshot of how that went. In 2019, there were conversations, issues were opened, consider merging AWS secret operator. So how did this work? So we have something called the controller pattern in Kubernetes. So one of the beautiful things about Kubernetes is that you can declare the state of things, that this is what I want, and Kubernetes tries to, ensure that that state is met. All right, so we have what we call the actual state, and we have the current state. All right, expected state and current state. So this is what I want. You're telling Kubernetes, this is what I want. I want to have 5 replicas of this application running. And Kubernetes says, okay, no problem, that will be done. If something happens to your application, maybe one of the replica dies, Kubernetes says, this has been defined, this has been declared that it must be 5. Kubernetes tries to bring another replica back up, right? So that's usually called the reconciliation loop or the control loop. And typically, when you look at cloud native technologies, they try to go towards this declarative approach, where I state what I want and I just allow the system to do its thing. All right, so that's what this operator follows. Now, this is just conversations on GitHub, how this solution was built or merged. But yeah, I was explaining how it works. Now, this is exactly what I just explained. So you have the desired state and you have the current state. Then the reconciliation loop begins to watch and begins to make changes. This is what has been declared. This is the desired state. Let's watch the system and adjust to fit. So if you have replicas that are more than what is expected, Kubernetes knows that I have to kill some things. If you have less than what is desired, Kubernetes knows that I have to put up some other things. So that's the controller pattern. And yeah, so this is just you know a broader way to look at this. You have a user, declare a cost. Now, if you use Kubernetes, you know that many of the things, for instance, a secret is a Kubernetes object, a deployment is a Kubernetes object, a do you know any other object? Stateful set, daemon set, all right. Those are config maps, yeah. Services. Those are objects in Kubernetes. But then Kubernetes allows you to create your own objects. All right, we call them custom resources. Custom resources. That's what Kubernetes allows because Kubernetes is not built for all solutions. Kubernetes is built specifically to do something, but it was defined or it was built in a way that you can extend its functionalities. Now, this is what I want to do. Kubernetes doesn't do that. Kubernetes doesn't manage secrets, but Kubernetes allows me to extend its functionality. I can build my own custom resources and it will work as I have defined it. Right? So now take an example. You use a default an inbuilt object in Kubernetes, config map. You can do things like kubectl get config map, right? So you can do stuff like that, and you can define your own custom resource and say maybe the resource name is Ileriayo. You can do kubectl get Ileriayo. That's what I'm trying to explain. It's not a Kubernetes, inbuilt resource, but you can build your own. Now, the operator pattern, or what you can see, the controller pattern allows you to do stuff like that. So that's what this exactly is showing you here. So you can make modifications, on your own custom resource and declare what you want. And Kubernetes looks at the system and it tries to adjust to fit what you have defined. So now, we built or in this solution, so we're saying we want to have, now I'll just paint a picture, all right, of what I'm trying to explain. We said that, let me go back a bit. Yeah. So we said we want to have external secret managers that are built for secret management. And we have our cluster, our Kubernetes cluster that speaks to the secret manager and tries to get, for instance, secrets. So you don't want to store your secret just somewhere else. You want to put it in your in your secret manager. For instance, you have thousands of secrets. Like we saw, the problem earlier was that as you begin to scale your system, multiple applications, multiple services, all of these things need accesses. All right, you have thousands of secrets to manage. You don't want to write them in a piece of paper, or you don't want to begin to, if you're working with a startup like I used to, you can store those things in your head. All right, you know that this is the password to this one. They call you that this is this. But when you're talking about scale, you have thousands, and it's a pain to actually begin to try to figure out a way to store those in your head. But yeah, you have the external secret manager. Now you have your cluster that speaks to the secret manager and says, we want to keep checking this secret manager. What's in here? You understand the pattern I explained? What is in here? We want to sync it with our cluster. I want to bring the secret. For instance, you have a Java application or a C# application in your cluster that needs a particular password to connect to the database, and you've defined, with your custom resource that this is where that secret is in Vault, Azure Key Vault, for instance, then Kubernetes goes to check and it keeps checking what password is here. When, for instance, you create it for the first time, but we'll see a demo. Now you create um, a secret in Azure Key Vault, and you define what Kubernetes is supposed to do to retrieve that secret. Kubernetes checks, it creates the secret in your cluster. Now you didn't have to go through all the hassle of, trying to manually create those secrets. Kubernetes checks, creates it in your cluster, and keeps checking. So, for instance, if there's a secret rotation in Key Vault, Kubernetes sees that, oh, this has changed, I need to reconcile. That's the operator pattern that I just explained. And so that's what this does. I'll just go back. So the APIs, now Kubernetes is simply you can call it a software, all right, just for clarity here. Now, and it has APIs that you use to access these objects in Kubernetes. But we defined our own custom resources, and we have the secret store and the external secrets. So the secret store refers to that, that where you're storing your secrets is quite intuitive. Where you're storing your secrets in HashiCorp Vault, in AWS SSM, in Azure Key Vault, that's the secret store. So that's what that resource defines. That means, how do I access this secret store? How do I connect to it? What secret store is this? Then now you have the external secret. The external secret is the secret in that store that you're trying to retrieve, that you're trying to get into your cluster, that you're trying to sync into your cluster. All right, and of course, the cluster secret store there is, I don't know if anybody can just make sense of, from what I've explained, if you can make sense of secret store, cluster secret store, external secret, cluster external secret. Okay, you wanted some kinds. Okay, well, but that's not what I was looking for. So, what differentiates secret store from cluster secret store? Thank you. All right. So the secret store is namespace scoped, but cluster secret store is, across your entire cluster. It's not scoped by namespace. So it's actually the same thing. The difference is the scope. Same for external secret and cluster external secret. It's namespace scoped. All right. Um, so this is what may not be clear. This is what the object looks like. So if you're defining a secret, for instance, you have your API version, whatever the version is, the same YAML manifest that you're used to. You have the kind, but this kind is a custom resource named secret store. You have your metadata, because it's namespace scoped, you have your namespace, and you have the spec that defines what, how to access this secret store itself. So that's what you have there. This is just this is an example using Vault. So Vault specifies the server, the path, the version, the namespace, yada yada yada. Then this is clear enough. Yeah, this is just another diagram to explain what we're saying. And this is external secret, the external secret object itself. So we're saying we're defining a resource named external secret. We're trying to, that's the name of the secret itself, hello world, and we're referencing the store, that this is the store where you will find that secret in there, all of that. But we'll see a demo shortly. This is also an extension of that. And before I go into this, I'll just move into a demo. So before now, I hope my service principal has not expired. But before now, I had already set up a cluster. Now, what do you need to use? This is Azure, by the way. All right. So this is Terraform script to provision an Azure cluster. So if you have any cluster, it works fine. Minikube, K3s, anything, something like Cube ADM, it works fine. But I'm not explaining Terraform, I'm not explaining AKS. But this is the script I used to create this, courtesy of a colleague of mine. All right, so I'll just quickly browse through. We have the network here, the subnet, all of those things. We have a secret object now. So we're using key vaults. All right, our secret store is key vaults. We're defining a secret object. All right, so we're storing our secrets in Azure key vaults. That's what this code does, and it shows you, yeah, that this just provisions the keyboard itself, all of the configuration and all of that. But then this is the secret that is stored in there. Is this clear enough? Okay. So this is secret that is stored in there. So I'm storing this secret in my key vault. All right. And I could have done, but I just have about 5 minutes more. So I've already done the Terraform apply here. That's what all of this is showing us. Terraform apply just applies the configuration and provisions the infrastructure. So I've already done that. And do, if I do this, get nodes, you see that I have a cluster already there 5 hours ago, 3 nodes. Then now this is my secret, my extra secret. Well, um, okay, I'll just share this. This is secret store, first of all. Ignore this tenant ID, please don't take a picture of it. But this is my secret store. I'm defining, um, I'm using Azure Secret Store, of course, like you see here. And I'm defining my service principal and all of those things, how to access the secret vault. This is the vault URL. That's the store. And this is the external secret. I'm trying to retrieve a secret from that secret store. This is it here. And this says every 30 seconds, try to get, so that reconciliation loop, it goes every 30 seconds to check, has this changed? If it hasn't changed, leave it as it is. If it has changed, update, and things like that. Then, of course, all of this can be read in documentation. There's a URL, for external secrets. By the way, external secrets operator last year made it to the CNCF sandbox. It means that it's widely known, it's widely used across the world. Yeah, so you should definitely check it out. Don't store your secrets. So let me just also point out that you, some of us might have found out, people that use Kubernetes, that when you create a secret and you store it in GitHub, for instance, that secret is not encrypted, right? Yeah, you can just do get secrets, blah 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 blah, base 64 decode, and you see your secret in public. Amen. Okay. So that's the way secrets are. So it's not really encrypted. Of course, you can do other things to get it encrypted and all of that. But Kubernetes, like I said earlier, was not built for all of that. External secrets operator helps you take care of all of that mess. Now, so this is the secret, the external secret itself, and those are the YAML manifests. So what I have done before now is just to do and apply. Uh, okay. So I did this. You know what this command does, right? All right. So I just did this and unchanged because I've already applied that. And because it's secret store, it's namespace scooped. If you look at the configuration here, it's in the ESO demo namespace. So I can show you that by doing, sorry, I'm using aliases for kubectl, for my kubectl client. So I can do kubectl get secret store from the namespace ESO demo, and it shows me that secret store. So remember, I said that these are custom resources that you can define. All right. The first thing I did on this cluster was to install the external secret operator, of course. So I said the requirement that you have a cluster, but actually the requirement is that you have a cluster with ESO, external secret operator, that's ESO, installed on it. And so that was done, yeah, using Elm. installed Ileriayo, the home chat, and all of that. So I've got ESO installed on this cluster, and that's my secret store. The status is valid and it's definitely ready. Then the next thing I did was define my external secret, which I showed us earlier, this one. And I'm trying to retrieve, from the Azure Secret Store, which I defined earlier, I'm trying to retrieve a secret. All right, demo, ESO demo secret. And that's what we have here. So I did that. So I can just do qctl get external secret from ESO demo. All right, so you can see what this says. Pardon me. Um, yep. So this is the secret itself as defined. This is the store where it is trying to pull secrets from, and the refresh rate is 30 seconds. All right. And if you can see here, it says secrets is synced. That means it's not out of sync essentially because of that loop. So if I change something there and it tries to find the secret, things just go weird. But yeah, that's the secret. Then I can get my, so I just created some helpful scripts. Um, I could run this now. Oh, sorry, not this. I had already done all of this, but I have a script that just creates that secret, all right, in there. I had already done all of this, and I have the source code in GitHub. However, it's not available at the moment. I had already created the external secret as well. I don't know this, but yeah, I want to show you what actually is in there. So if I get the current secret, that is 4. Now show us the script, of course. So this is this script, and what it does is basically I'm just setting an alias for, just to base 64 decode the secret itself, piping it to cow say. Cow say is that cow object that you see here, and then of course I'm using the lolcat for the colors, so it's nothing fancy. But yeah, this is what I'm actually doing. I'm doing kubectl get secrets from the ESO demo, and that's the secret name, secret from Azure Key Vault. Then I'm trying to find the secret data itself. All right, I'm trying to get the secret data and I'm piping it to the code base. So this is the secret. Hello, localhost Meetup. So if I go to Key Vault and I update that secret, this is my cluster, by the way. This is coming from my cluster, secret from my cluster. If I go to Key Vault and I update using this command, all right, so I can just do that. So I've updated the secret in my key vault. All right. Whoever is in charge of the secret manager can do whatever they like. ESO just checks and brings whatever is there back to you. Then if I go back to get my secret, um, it might take 30 seconds, but let's see. So I don't know if you noticed the secret before now was hello localhost meetup blah blah blah. But yeah, because I updated it, updated the value in key vault, then ESO just went there and resynced. So we have this updated secret. So that's ESO under the hood, powerful but simple. All right. Then the current state of ESO, this is how he grew. Version 0.2, we integrated with some secret management tools, parameter store, secret manager, HashiCorp vaults, and all of that. But the interesting part that a lot of people requested for is this one in version 0.7. Now there's the other versions, is 0.8 as well, bug fixes. But 0.7 now did something. So when you say we're syncing secrets, the demo I showed us was we're updating key vaults and ESO is bringing the secret from key vaults. But some people said, how about we update the secret in the cluster and it updates keywords? That's what happens in 0.7. So it's magical. And that's how we are. That's the current state. The star history is over 2K, all right, used by a lot of people. Beautiful tool, I must say. And these are the supported providers: AWS, Azure, Google, IBM, Achilles, GitLab, One Password, Kubernetes. I'd already done the demo. Yeah, so you can contribute. If you can go line, that is it. Thank you.
All right. Hi everyone. So I want to ask, how possible is it to niche down to the exact score? Because I
Somebody, I
believe
think I just it.
people are like comparing to other alternatives. So you're talking about hash code faults. Sorry, hash code faults. And what it does is that it ties the service account and gives that code an identity. So basically, how it works is that, yeah. So how it works is that the service account has the identity of the pod, which gives the pod permission to actually query some necessary secrets, which is actually hosted within that cluster. So basically, what that, okay, let's say, like your kids, you have the first local point of call, whereby it holds other external secrets outside maybe Azure and the rest. Then upon that, it now like gives an identity of a pod. So you can be able to query some necessary secrets within a specific block. Yeah, like basically like that. So in this kind of scenario, how do you handle that kind of thing? Because what I'm saying here is that we're just niching this thing down to a particular namespace and all. So doesn't every other pod within that namespace can have access to that secret?
Okay. Yes. Should I? Okay. All right. So, um, yes, every other pod can have access to it, but you're probably defining a different problem. All right. What this does is to sync secrets. All right. That's not the primary. Now, I'm not sure if something has been implemented. All right. I followed it up to 0.70, which I was interested in. I don't know if something has been implemented, but of course, you can contribute. But nice question, actually. The security official.
For the presentation. So my question is, Bitcoin. I don't know, you didn't mention Bitcoin here. So
I think Bitwarden is part.
first
I
Bitcoin, and
think
then so Bitcoin has this feature where you can group secrets by like a collection. So all the secrets under that collection sort of belong to one application as to be regulated. Now I don't want to have to reference secrets one by one. I just want to reference that collection and the secret, all the secrets on that collection should be available to the namespace. Is that possible?
can just quickly check the documentation. But I don't know if people. So my colleague, somebody who has worked on this application as well, is here. I don't know if you got that question. So he was asking about the demo I showed. You're about retrieving just one secret. That's. But he's saying, for instance, Bitwarden as an external secret manager has collections that you can retrieve like multiple secrets from. I don't know if ES2 does that.
Hello everyone. Um, Depending on the type of cloud or cloud you're using and the secret type. So, for example, you could have AWS Cloud Store. It will only store maybe key value pairs of secrets. When you reference that particular secret name in that particular cloud, all of the key value pairs within that store is going to be made available to you in Kubernetes. If I get the question correctly, I say if you have, I think that's it, right?
Yep, yep.
So it depends on the type of secrets
Exactly.
of the cloud. So, for example, AWS might not be able, AWS Secret Manager that I'm sure of would have like key pairs values, and all of that is going to be referenced, so you can make a reference in the secret.
Yeah. Thanks. So to add to that, so it's possible. That's just implementation detail. All right. We have different providers.
Thank you. One more question.
Thank you very much. Thank you very much. Mr. Larry,
Random fact. Random fact. You're Nigerian.
okay, so I was asking the contract and help on how I was doing master, marriage, and all that. So, it was because I went through a lot. Having to get somewhere to myself. And just afraid. I'm not happy for anything. I just want to learn. So I reached out to a friend and he forwarded my signature. For the past 2 weeks, we've been waiting for the back, because I'm back 100%. So yesterday, I got a mail from him telling me I can have my interview as okay, so if I'm deploying my details on the domain and I want to see the manager on your I don't know that.
It works. It works.
So I don't know that.
I can send you the link. But it works as you have defined.
I'm sure you will answer it.
Eh? No, I think I've answered it. So yeah, you can have your cluster anywhere, and you can have your secret manager anywhere. I hope that's clear. Yeah. Thank you.
If you have any other question for him, you can see him after service. It will be outside.
You can also meet me on Twitter or LinkedIn.